There is a very specific type of vertigo I get when I walk into one of those trendy industrial chic coffee shops. The ones I'm talking about.
Oh, yeah, the ones with the reclaimed wood tables and
And the barista who definitely judges your oat milk order.
exactly.
But it's not the coffee that gets me, it's the ceiling. I always find myself leaning back, looking past the Edison bulbs and the matte black paint, and just staring at the absolute chaos up there.
It really is a jungle.
It is. It's this web of pipes, water lines, gas lines, sprinkler systems, HVAC ducts. It looks like a heavy metal jungle gym suspended right over your head.
And most people treat it as visual background noise, but if you actually stop and focus, you are looking at a massive, incredibly complex circulatory system.
That is the perfect way to describe it, a
Right.
circulatory system. And recently, I had this moment of realization. I was staring at this exposed ceiling, and I stopped looking at the pipes and started looking at the things holding the pipes.
The supports.
Right, the amount of hardware involved just to keep those things from crashing down onto my latte is staggering.
It's definitely not just a piece of string and some hope, that's for sure.
No, not at all. And I was looking at the source material we have for today's deep dive, and the list of specific items is honestly overwhelming. We're talking about BOCA plates, nail plates, stud guards, stud shoes.
And those are really just the protective elements.
Right, then you get into the hangers themselves. Iron swivel rings, clevis hangers, two-hole wrap straps. It sounds like an inventory list from a medieval armory or something, but it's all plumbing hardware.
It does sound pretty intense.
It really begs the central question we are tackling today. Why? Why do we need so many specific, distinct items just to hold a round tube against a flat wall?
It seems excessive until you understand the actual stakes involved.
Right, like why can't we just use some heavy-duty duct tape or a generic metal loop and call it a day?
Please, if you are listening to this, for the love of structural integrity, do not use duct tape to hold up your plumbing.
I won't, I promise. But that is the mission for this deep dive. We are going to unpack the critical and frankly often invisible world of steel pipe fasteners. We're basing this discussion on technical insights and catalogs from the Dundee Manufacturing Company.
And they are a fantastic source for this. They're known in the industry as the Can-Do Company. They are a major producer of high-strength, made-in-USA steel fasteners. They take the engineering of these little metal parts incredibly seriously.
And looking at their data, it is abundantly clear this isn't just about holding stuff up.
No. If you take one thing away from our conversation today, it should be this. Fasteners aren't just shelf brackets. They're about preventing premature system failure.
Premature system failure.
Exactly. We are talking about safety, stability, and the longevity of the entire building. Whether it's a residential home or a massive industrial plant, the things holding the pipes are just as critical as the pipes themselves.
Premature system failure sounds very expensive and very wet. So let's unpack the why. Because if gravity were the only enemy, I feel like my duct tape solution might work for, well, at least a week.
Maybe a day.
Fair enough. But the Dundee material highlights a triad of enemies that these supports have to fight.
Right. Gravity is the obvious one, the constant downward pull. But the other two are where the engineering really comes in, vibration and structural stress.
Vibration is the one that really caught me off guard. I don't usually think of my plumbing as moving. It just sits inside the wall.
It sits in the wall, but it is alive. Think about it. Every time you turn on a faucet, water rushes through those pipes at a really high velocity.
Okay.
And every time a valve slams shut, like your washing machine or your dishwasher, you get a literal shock wave. That is kinetic energy bouncing around in there.
It's like that thunk sound you hear sometimes.
Exactly, the water hammer effect.
Yeah.
That energy has to go somewhere. If the pipe isn't secured properly, that energy vibrates the pipe. And vibration is the silent killer of plumbing.
Because it shakes the joints.
Precisely. You can have the most perfect, beautiful, soldered copper joints in the world, but if you wiggle them back and forth a million times over 5 years, you get metal fatigue.
Oh, wow.
Yeah, microfractures develop. Then you get a pinhole leak. Then you get mold behind your drywall. And all of that is just because the fastener allowed a little too much play.
So the fastener is essentially acting as a shock absorber.
In a way, yes. It has to be rigid enough to hold the weight, but positioned correctly to manage that movement. The source material explicitly talks about extending system lifespan. That's the key insight here.
You aren't buying a strap to hold a pipe for today.
No, you're buying insurance that the pipe will still be holding water in 2050.
I really like the idea of looking at it as insurance. Now let's get into the nitty-gritty, because the Dundee catalog is honestly like reading a chemistry set.
It is very thorough.
I'm seeing an entire rainbow of metals here.
Yeah.
Galvanized, plain steel, stainless steel, copper-coated, zinc-plated. Why do we need so many flavors of metal?
This brings us to the first major rule of plumbing hardware: material compatibility. If you ignore this rule, you are basically guaranteeing a failure.
So I can't just grab a strong steel strap and slap it onto a copper pipe. I mean, they're both metal. They're both strong.
They are both metal, but they hate each other. It's a phenomenon called galvanic corrosion.
Okay, lay some science on us. What exactly is galvanic corrosion?
Think of it like building a battery. When you touch two dissimilar metals together, like copper and carbon steel, and you introduce an electrolyte.
Like sports drink.
Well, in a building, the electrolyte is usually just ambient humidity or a little bit of condensation sweating on the outside of a cold water pipe. But yes, same principle. When you have those three things, you create an electrical current.
So you are literally building a very slow, very destructive battery in your ceiling.
Exactly. One metal becomes the anode, the other becomes the cathode, and the anode gets eaten away. In the specific case of a copper pipe and a steel strap, the steel corrodes rapidly. You'll see it if you ever open up an old wall. It's this crusty, green, and rust-colored buildup, and eventually the strap just completely snaps.
That is a terrifying image. The pipe just sitting there eating the strap, holding
It
it.
happens all the time in DIY jobs. People just use whatever they have lying around in the garage.
So, looking at the Dundee guide, if I'm running copper piping, what is the absolute must-have pairing?
You match the material. Dundee specifies using their copper-coated or solid copper straps for those applications, or for some specific industrial applications, stainless steel can work because it's relatively inert. But the gold standard is copper on copper.
You want to eliminate that chemical warfare potential entirely.
Right. Match like with like.
That makes perfect sense.
Okay.
What about steel piping then?
Steel piping is generally much heavier. Think of big gas lines or overhead fire sprinklers. So there, the focus shifts slightly away from the chemistry and more toward pure load capacity. You need heavy-duty steel hangers that are rated for those significantly higher loads.
And then we have the modern contender in the ring, PVC. It's plastic pipes. I feel like you could use pretty much anything for plastic, right? It's not going to rust.
It won't rust, but it has a completely different vulnerability. The source warns specifically about deformation.
Squishing it.
Right, squishing it. Steel has incredibly high tensile strength. You can crank a bolt down on a steel pipe with a wrench and it's totally fine. If you do that to a PVC pipe, you ovalize it. You crush the plastic.
Oh, because it's so much softer.
Exactly. And plastic, unlike steel, is susceptible to something called creep. It changes shape over time when it's under constant pressure. So if you crush it slightly today, it might actually crack open 2 years from now.
So for PVC, the fastener needs to be gentle.
Snug is the engineering term the source uses. It needs to support the pipe without constricting it. And you also have to look at the environment. Dundee makes a really big point about corrosion-resistant coatings for outdoor or high-moisture areas.
Right, like if you're in a damp basement or outside in the elements.
Exactly, because if you use a cheap, plain steel strap in a damp basement, the strap rots away, and suddenly your perfectly fine PVC pipe is lying on the floor. It doesn't matter that the chemistry between the pipe and the strap was fine if the ambient air eats the strap.
So it's a matrix. You always have to consider the pipe material, the strap material, and the air around them.
It's a multidisciplinary decision every single time you hang a pipe.
This leads perfectly into the second factor they talk about. Sizing. I call this the Goldilocks principle. It can't be too loose, can't be too tight. But honestly, isn't a 2-inch pipe just a 2-inch pipe?
You would certainly think so. But in the plumbing world, 2 inches is more of a vague category than an exact measurement.
Wait, really?
Yes. And this is where the professional grade stuff from a company like Dundee really separates itself from the generic stuff you might find in a bargain bin. There is a fundamental difference between iron pipe size, which is IPS, and copper tube size, which is CTS.
Okay, so a 2-inch iron pipe has a different outside diameter than a 2-inch copper tube?
Exactly. The inside might let the same amount of water through, but the outside is a different thickness.
So if I buy a generic 2-inch clamp, it might fit the iron but not the copper?
Right. If you try to use a strap designed for iron pipe on a copper tube of the same nominal size, it will likely be too loose. It will rattle when the water runs. If you do the reverse, you'll end up crushing the copper tube trying to get it closed.
That explains why their catalog is so thick. They aren't just selling small, medium, and large. They're selling highly specific diameters for highly specific material standards.
Precisely. It is all about maintaining that structural integrity we talked about. You are cradling the pipe, not just catching it if it falls.
Let's talk about weight next, because I think this is the hidden variable that most people, myself included, don't think about. I
Yeah.
picked up a piece of PVC pipe at the hardware store the other day to fix a drain under my sink, and I could literally spin it on my finger. It weighs nothing. So why on earth do we need these heavy-gauge industrial steel supports for lightweight plastic pipes?
Because you aren't supporting the pipe. You are supporting the column of water inside the pipe.
Right. Water is heavy.
It's extremely heavy. It's roughly 8.3 pounds per gallon. Let's do the math on this really quick. A standard 4-inch drain pipe, which is common for a main line in a house, holds about 2/3 of a gallon of water per foot of pipe.
Okay.
So if you have a 10-foot run of that pipe across your basement ceiling, you aren't holding up a few pounds of hollow plastic. You're holding up over 50 pounds of water plus the weight of the pipe itself.
And that is just a static load.
Yeah.
That's just the water sitting there doing nothing.
Right. Now add the dynamic load we talked about earlier, the water rushing through, the pressure changes, the vibrations. Dundee emphasizes heavier gauge steel pipe fasteners for this exact reason. You need a massive safety factor.
A safety factor meaning you over-engineer it.
Yes. If the system weighs 50 pounds, you absolutely do not want a strap rated for 51 pounds. You want a strap rated for 200 pounds. Because real-world conditions change. Sludge builds up inside drain lines over the years, making them much heavier. Or, heaven forbid, someone decides to hang a wet winter coat on a pipe in the basement.
Which people definitely do all the time.
Which they absolutely should not do, but the fastener has to be able to handle that reality. Dundee points out the importance of verifying load ratings against building codes like the IPC and UPC. You just can't guess with this stuff.
Okay, so we've got the right material, we've got the right exact size, and we've got the right strength rating, but now we have to actually put them up on the wall or the ceiling. This is where the rhythm of installation comes in. How do you decide where to put the straps? Is it just wherever there happens to be a wooden stud?
That is the classic handyman special approach, and it is asking for a disaster. There are strict code rules on spacing, and again, it all goes back to the material properties, specifically how rigid the pipe is.
Walk us through the hierarchy here. Let's start with copper.
Copper is metal, so it's fairly rigid, but it is a relatively soft metal. If you span it too far between supports, it will bow under its own weight. The standard guideline is typically to support it every 6 to 8 feet horizontally for the smaller diameters.
Okay, 6 to 8 feet. That seems pretty manageable. Now, what about the floppy one, the PVC?
PVC is really the high-maintenance child of the plumbing world when it comes to support. Because it is a thermoplastic, it will sag significantly if it's left unsupported. The rule is strictly every 4 feet for most common residential sizes.
Wow, every 4 feet. That is twice as many supports as copper in some cases.
It is, and this is exactly where people try to cheap out. They switch from copper to PVC to save money on the raw materials, but then they try to use the copper spacing rules to buy fewer hangers.
And the result?
The pipe sags right in the middle between the supports.
And why is a sag so bad, apart from just looking unprofessional and ugly?
It fundamentally destroys the function of the pipe. Most of these PVC pipes are drain lines, meaning they rely purely on gravity to move waste out of the building. You need a perfect, consistent slope, usually a 1/4 inch of drop per foot. If the pipe sags in the middle, you create what plumbers call a belly.
A belly. That does not sound good for plumbing.
It's terrible. Water just sits in the belly, solids settle out and get stuck there. Eventually, you have a massive clog. Or the sheer weight of that standing water pulls even harder on the glue joints, which eventually leads to leaks. It creates a cascading failure throughout the whole system.
And what about steel pipes?
Steel is the most rigid of the three. It typically allows for a much wider spacing, though it obviously depends heavily on the diameter and the load. But generally speaking, you can go further between supports with steel than you can with PVC or copper.
What about going up and down, like vertical piping in a multi-story building?
Vertical rules are actually a bit simpler. Typically, you need support at each floor level. This supports the sheer weight of the vertical stack, so the whole column of pipes doesn't just slide down the shaft and crush the fittings at the bottom.
That makes a lot of sense. So proper spacing essentially keeps the system straight and true. It prevents that sag, which really seems to be the root of all evil here.
It really is. Sagging pipes are a plumber's nightmare.
Okay, so let's say we have bought the best made in USA Dundee fasteners.
Yeah.
We've got the exact right ones for our pipe. We know exactly where to put them every 4 feet or 6 feet. But here's the curveball, the human factor. You can still completely mess this up, can't you?
Oh, absolutely. Installation is where even the absolute best hardware in the world can fail if it's applied incorrectly by the installer. The Dundee source material has a great section on installation best practices, and it points out some really common errors that happen on job sites every day.
The first one listed here is anchors.
Right. You cannot just screw a heavy pipe hanger into standard drywall. Drywall has essentially zero structural strength for pulling loads. You have to fasten to structurally sound surfaces, wood studs, concrete, masonry block, and you have to use load-rated anchors for those materials. If the anchor simply pulls out of the wall, it doesn't matter how strong the steel strap was.
That feels like a life lesson, honestly. It doesn't matter how strong you are if you aren't anchored properly.
Very deep, but very accurate.
Next on the list is something I truly had never considered: thermal expansion.
Yes, this is a highly critical point that the experts always emphasize. You have to allow room for thermal expansion. Think about a hot water pipe in your house. When you turn on a hot shower, that cold copper pipe suddenly heats up, and metal physically expands when it gets hot.
So the pipe literally gets longer.
It does. A 100-foot run of copper pipe will expand about an inch if you run standard hot water through it. Now, an inch doesn't sound like much over 100 feet, but if you have that pipe clamped down completely tight at both ends...
Something has to give.
Exactly. It will bow in the middle, it will buckle, or it will literally rip the fastener right out of the wall structure. Or, in less extreme cases, it will make that weird ticking sound inside your walls. You know that sound.
Yes. The ticking ghost in the wall. I always wondered what that was growing up.
That is almost always a hot water pipe trying to expand and aggressively rubbing against a wooden framing member or a metal clamp that is secured too tightly. Dundee emphasizes allowing for this expansion. You often leave the strap just loose enough for the pipe to slide axially back and forth, while still holding it securely in the vertical direction.
So alignment isn't just about making it look straight and pretty. It's about not preloading the system with mechanical stress.
Right. Don't physically force a pipe into place and then strap it down while it's under tension. That built-in tension is just a time bomb waiting to snap a joint. Line it up naturally, then secure it.
And finally, maintenance. The source says, inspect supports regularly.
Especially in commercial or industrial environments, constant vibration slowly loosens screws. Ambient moisture causes surface rust. It is not a set-it-and-forget-it situation forever. You need to verify that the supports are still doing their job years down the line.
Now, amongst all these different products, the clevis hangers, the swivel rings, the stud shoes, there seems to be one star player in the catalog that keeps popping up over and over: the galvanized pipe strap.
Ah, yes, the absolute workhorse of the plumbing industry.
Why does this one specific item get so much love and attention?
Because it elegantly ticks all the boxes we just spent the last 15 minutes discussing. First, material strength. The Dundee galvanized straps are noted for being a heavier gauge of steel than the cheap alternative.
So they are incredibly strong.
Very strong. Second, corrosion resistance. That galvanized coating is essentially a sacrificial layer of zinc that completely protects the structural steel underneath. It significantly extends the service life, preventing that premature rusting and failure we talked about.
And I see here in the text they also mention finish quality and ease of use.
Yes, specifically the pre-drilled holes. Now that sounds like a very minor detail, but imagine being an installer balancing on a tall ladder. If you are hanging 500 feet of pipe in a dark warehouse, having clean pre-drilled holes that are perfectly consistent makes a massive difference in your daily efficiency.
And that's the real business case, right?
Mm-hmm.
High-quality fasteners reduce job site delays and, quoting the source here, minimize callbacks.
Exactly. Let's talk about the callback for a second. A callback means the plumber has to drive all the way back out to the job site a week later because something is rattling inside a wall or a pipe is leaking. That costs the company time, gas, and valuable labor.
And their reputation.
A huge reputation cost. If a contractor saves 50 cents by using a cheap, flimsy strap, but it sags and causes a rattle, and they have to spend half a day driving back to rip open a wall to fix it, they have just lost hundreds of dollars. Using a better strap, like a high-quality Dundee fastener, is essentially very cheap insurance against callbacks.
So let's wrap this up. We have gone from looking at what appears to be a simple, boring metal loop to understanding that it's actually a highly complex engineering decision. We've got chemistry preventing galvanic corrosion, we've got physics handling the water load and gravity, and we've got geometry dictating the exact spacing to prevent sagging.
It really is a multidisciplinary engineering challenge hidden in plain sight.
And I really like the underlying philosophy that Dundee Manufacturing puts forward in their materials, built for strength, built to last. They make the implicit point that they aren't just stamping out metal parts, they are actively protecting the entire plumbing system.
That is the core takeaway.
Yeah.
The fastener is the silent guardian of the pipe. The pipe itself gets all the glory because it's the thing that actually carries the water to your sink, but the fastener provides the stable environment necessary for that pipe to survive for decades.
I want to ask everyone listening to try something today. Next time you are walking through a parking garage or a big box store warehouse, or honestly even just down in your own unfinished basement, look up. Try to imagine that industrial cityscape of pipes running in every direction.
And pay attention to what is actually holding them up there. Look for the swivel rings, look for the clevis hangers, spot the beam clamps on the steel girders.
It's a whole different world up there once you know what you're looking at.
It really brings up a final thought for me about all of this. We live in a world surrounded by massive infrastructure that is essentially completely invisible to us. We turn on a tap, clean water comes out, we flush a toilet, waste goes away safely. We take it entirely for granted every single day. But the only reason we can afford to take it for granted is because of these tiny, unglamorous pieces of engineered steel.
That is so true. We really only notice these systems when they violently fail.
Exactly. The fact that you don't spend your day worrying about pipe fasteners is the ultimate proof that they are out there doing their job. They are holding the modern world together, quite literally, one two-hole wrap strap at a time.
I know. I'll never look at an exposed coffee shop ceiling the exact same way ever again. Thank you so much for taking this deep dive with us today.
It was my pleasure.
And to everyone listening, we will see you next time.